Amedeo Avogadro was an Italian scientist. He gave his name to the number of particles in a mole. Maybe you don't yet know what a mole is. If so, just have a look at our video on moles before moving on with this lesson. Avogadro's number, Na, or the Avogadro constant, is 6.02 times 10 to the 23 particles per mole. It is the number of atoms per mole of the carbon-12 isotope. For atoms, the mass of Avogadro's number of particles is equal to their relative atomic mass in grams. So, the mass of Avogadro's number of hydrogen atoms is 1 gram, and the mass of Avogadro's number of chlorine atoms is 35.5 grams. For molecules, the mass of Avogadro's number of particles is equal to their relative molecular mass in grams. So, for example, the mass of Avogadro's number of hydrogen molecules, or H2, is 2 grams, and the mass of Avogadro's number of chlorine molecules, Cl2, is 71 grams. If someone asks you, what is the mass of Avogadro's number of chlorine particles, it is impossible to answer the question without the person going into more detail. If by chlorine particles they mean chlorine atoms, the answer is 35.5 grams. If, however, by chlorine particles they mean chlorine molecules, the answer is 71 grams. In 1811, Avogadro proposed his hypothesis which stated, equal volumes of gases at the same temperature and pressure contain the same number of molecules. This hypothesis made it easier to perform calculations involving gases. This means that 1 mole of any gas will occupy the same volume as 1 mole of any other gas, provided that they are at the same temperature and pressure. The volume occupied by 1 mole of a gas is called the molar volume. Molar volume is measured in decimeters cubed per mole. At room temperature and pressure, the molar volume is taken as 24 decimeters cubed per mole. Let's look at an example. What is the volume occupied by 4 grams of oxygen at room temperature? Do you feel ready to work this out yourself? If so, pause the video while you work it out and press play to resume to get the answer. Okay, so let's look at what we already know. We know that 1 mole of any gas at room temperature occupies 24 decimeters cubed. 1 mole of oxygen gas, O2, has a mass of 32 grams. So, 32 grams of oxygen gas at room temperature occupies 24 decimeters cubed. Therefore, 1 gram of oxygen gas at room temperature occupies a volume of 24 divided by 32 decimeters cubed. And so, 4 grams of oxygen gas at room temperature occupies a volume of 4 times 24 over 32 decimeters cubed, or 3 decimeters cubed. Did you get it right?